We are starting now week 7 of online learning. I know that feels like a very long time, because it has been. This video specifically is going to discuss calculating mean. Um, just to run through kind of what's on the screen for you guys, you have your weekly tracker. Make sure you keep up with it. That is on the left here. Do this week. What you're going to notice is there's a lot more Google Slides. The reason for that is I talked to a few of you guys, and a lot of you guys prefer the Google Slides or mixing it up a little bit as opposed to just doing the quizzes over and over again. So I threw some of those in. Hopefully you guys enjoyed those through the week. And our office hours are listed down in the bottom right. Please use those as needed. Now let's go ahead and get started here. This week is all about measures of central tendency and range. Now, Monday's lesson specifically, which is today, is on calculating mean. And before we kind of dive into mean, we have to develop some real-world context here. So let's take a look at something like this. Ryan has been tracking the number of views of the company's website every day for the past 5 weeks. He needs to determine which day of the week is ideal for posting new promotions. Ryan must find the mean, median, mode, and range for each day to analyze the situation. So a lot of companies, specifically if they have online brands, use information like mean, median, mode, and range, and obviously a lot more in-depth kind of analysis in order to determine things like when should I post, what should I post, who's viewing the post, things like that. So in this context, Ryan is using the simple mean, median, mode, and range in order to analyze this situation. So with that in mind, in the real world context in mind, we have some important vocabulary here, and we'll be working on this, like I said, throughout the week. But today we're specifically focused on mean. So notice the pencil and notebook coming up. Make sure you write this down. What mean is the sum of the values of the elements in a data set divided by the number of elements. Now, when I say elements, I mean the number of numbers or the number of values here. So this brief example, we have 3 separate elements or values being added together, 2, 4, or 7, and you would divide it by 3 to get 5 because there are 3 elements or values in this data set. Calculating mean. Mean and average are the same thing. I will say that again. Mean and average are the same thing. So when you're finding average, you're finding mean. When you're finding mean, you're finding average. Once again, to find the mean, you find the sum of all the elements or all the numbers and divide it by the number of numbers that are there, or the number of elements, which you'll see. So on this right-hand side, notice once again, you got the pencil and notebook. If we have this data set, 6, 8, 8, 9, 1, 3, 3, 8, 9. The first thing I'm doing is I'm finding the sum. Sum deals with addition. So I'm adding all of these numbers up. When I sum these, I got a value of 55. The average is not 55. Remember, the average is a representation. It's a measure of centrality. So the average or the mean should be somewhere near the middle of your numbers. 55 is nowhere near the middle of the numbers here in our data set. So that's just kind of a quick check. Does that make sense? It doesn't. And the reason we're not there yet is we then have to divide by the number of elements or the number of numbers that are there. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. So you take that sum of 55 and you divide it by 9. And if you do that, you're going to get this 6.1 repeating, non-terminating decimal. So that's why you see that line here. Now, I want you guys to actually pause the video and try to calculate this one, and then check it when you're done. When you were solving this, hopefully you use the reference on the right. It's a very simple 2-step process. The sum is 243. Now, once again, it's not our average. That number is not near the center of these because I need to divide it by the total number of elements in this data set. And there are 1, 2, 3, 4, 5, 6, 7, 8. So 243 divided by 8 gets an average or a mean of 30 and 375 thousandths. So this value here is our average or our mean. Now, I want to, before we move forward, direct your attention to this value right over here. Okay? This value is what is called an outlier. Now, an outlier is an element or a number in the data set that is drastically different, either greater or less than, so it can be way bigger, way smaller, than the rest of the numbers in the data set. Outliers have a huge impact on the average because they drive the average way up if it's bigger than the rest of the numbers, if it's greater than the rest of the numbers, or it drives the average way down if it is lower than the rest of the numbers. So for instance, if you're a student who is an A student and you get 4s on everything, 90% on everything, 95%, right? 3s and 4s always. If you get a 1, and that's like an outlier for your performance, it's going to take your grade down pretty quickly, especially if you're at like 100% A. All right, because that number it takes your grade way down. Now, if you're a student who kind of struggles a little bit more, getting that 4, which may represent an outlier for what you would normally get, really helps you in the positive direction, okay? So outliers, when they exist in a data set, mean is not the best to use when there is an outlier. It's not going to give you a good representation. That does not mean, for instance, the mean doesn't exist in the data set, because it does, right? Our mean, we calculated it. It's just because of this outlier here, which has a huge impact on our average or our mean, it's really not the best measure to use, and we'll discuss that when we get to things like median and mode later in the week. Now, example number 2 here. Make sure, once again, note you're writing this down. If the mean is 23, what is C? So we have this data set. And what we're going to do is, using the definition of mean, we're going to find C here. To be clear, C is a variable. C is an unknown. We're not sure what it is. But we know when we add these 1, 2, 3, 4, 5, 6 different elements or values together and then divide by 6, we get 23. So I can use this to set up an equation. I know 20 plus 33 plus 21 plus C plus 20 plus 39. When we divide it, make sure I get the right colors here. When I divide this entire thing by 6, once again, 6 coming from the fact there are 6 elements or 6 values in our data set, I should end up getting 23. Because that's the definition of mean or average, right? You add all your numbers, you divide by the number of numbers, and that's your mean. And we know the mean is 23 because it tells us right here. Now, how am I going to solve this? Well, the first thing I want to do here, and you can do 2 different things first. What you can either do is add all of these values at the top. Keep in mind, C would need to stay by itself because it's not a like term. But you can add all the constants, or you can get rid of this division first. I'm going to get rid of the division first. And the way you get rid of a division by 6 is doing the opposite, which is multiplying by 6. Now, keep in mind, you need to do the same to both sides of the equation. We have gone over that over and over again within multiple lessons. So what you end up getting when you multiply that by 6 is you still have your numerator here. And now on the right side of the equation, we have 138 because 23 times 6 gets 138. Now at this point, we have a fairly basic equation. What I'm going to do on my left is I'm going to combine all of my constants to simplify this down. And adding all the constants gets 133. Now at this point, I'm going to subtract 133 from both sides, and I'm going to get C equals 5. So that tells me that this is my data set. Now I'm going to add these little brackets here. You will see this brackets fairly often when you're dealing with mean or average. So this should be my data set. Now I am going to check my answer. Well, how do I do that? The question says the mean is 23. So I'm going to calculate the mean of this and make sure it is 23. So I'm going to add all of these up and divide it by 6, and I indeed get 23. I just did that on my calculator. So because that is the case, C is 5. That is the correct answer. As I emphasize all the time, guys, take the time to check the answer. It doesn't make sense when you know you have a way to check that you get it right to not take advantage of that. So C here is equal to 3. Now we're going to apply that same logic here to our next example. It's just expanding it to a word problem rather than just a data set that's just given to you. So the mean weight of 5 complete computer stations is 167 and 2/10 pounds. The weights of 4 of the computer stations are given here. What is the weight of the 5th? So I'm going to move through this example a little quicker because it's the same general idea. Now I'm going to make this time X stand for the 5th computer station. So 158 and 4/10 plus 162 and 8/10 plus 165 plus 178 and 2/10 plus X. When you divide it, hopefully this is still red. Yes, very good. When you divide it by 5, because there are 5 elements here, you have 1, 2, 3, 4, and 5. Remember, X is a value. We just don't know it yet. But that should end up equaling 167 and 2/10 pounds. All right. Just like I did last time, I'm going to get rid of that divided by 5. By multiplying by 5, they are inverses, therefore they undo each other. Make sure you do it to both sides. All right, 167 and 2/10 times 5 gets 836. So now what I'm left with is this that I'm typing on the left, and that's going to end up equaling 836. I just want to reiterate too, just because there's decimals, the process does not change. Don't get overwhelmed, guys, when you see decimals, especially right now since you have access to a calculator to do this, because I want you to demonstrate the ability to know how to do it, not how to add or divide right now. So on the left-hand side, I am combining like terms. Then I am subtracting the 64 and 4/10 in order to isolate. And I'm going to get X being 171 and 6/10. Now, I'm not just going to go ahead and say, oh, I for sure did that right. If this is right, my data set is as follows. Excuse me there. So that should be my data set. And remember, my mean should end up being 167 and 2/10. So right now, my calculator, I am adding these values in my data set. And I am dividing by 1, 2, 3, 4, 5. And I indeed get a value of 167.2. So I know this represents our unknown value. This is correct here. Okay? Always take that effort to check it. All right? Especially since it can correct mistakes. A lot of times there's an addition mistake in your calculator, or you divided by 4 instead of 5 maybe. So take time to check that answer. All right, now really quickly, I am going to just spin on over to today's activity so it is clear what I need you guys to do and turn in for today. This is what's called a Pearson puzzle. What a Pearson puzzle does here is you're going to solve, obviously, math questions, but you're going to get some useful real-world information on someone important in history. And in this case, it is Jackie Robinson. So the instructions here are on the second slide as I go past to the third slide. But the directions here are very straightforward. You're going to solve 8 different problems. You're going to show work in the space provided. That is important. And then each correct answer will give you a missing piece of the person's biography, okay? And then you're going to drag the clues into the sentences where the blanks are provided. If the blank is not large enough, you may place it below the sentence. Here we have just a little bit of introduction in terms of who Jackie Robinson was. And if you are really into sports, and even if you're not, an incredible, powerful, and impactful person in the history of the United States. He broke the what's called color barrier in Major League Baseball, and I know baseball is not as popular now, and a lot of you guys probably actually don't watch it. But back when he broke in, baseball was America's pastime. Still is technically, but it was the most popular sport. So imagine kind of like the NFL. MLB was that. So he faced a lot of racism and bigotry and things like that as he entered and played for the Brooklyn Dodgers. Now, there are 8 questions. For instance, up here in question number 1, Robinson was born in Cairo blank. All right? What you're going to do is you're going to answer the question, what is the mean of this data set? Now, I will do the first one for you so I can just demonstrate how to do this. So I am adding my 1, 2, 3, 4, 5 elements. I am dividing by 5. I get an answer of 4. So in here, I'm going to show my work. So I would do something like 2 plus 2 plus 3 plus 5 plus 8. That equals 20. And then I can type something like 20, sorry about that, divided by 4, or divided by 5, equals 4. So I'm going to take the time to show my work there. Now I am going to yellow box the answer, which is here, and then I am going to drag this answer choice up here. All right. So this is what your slide should look like. Maybe your yellow box here is a little neater. You shrink it down and extend it over the 4, make it look nice and neat. But this should not take you that long, really. There's only 8 questions. They're pretty simplistic. But this is what I'm looking for. Drag and drop the correct word answer up here. Show your work in this box. Highlight your answer down here. And that's it for all 8. And then that will complete your work for Monday. And then you can choose to either take that break or you can just keep pushing forward and move on to Tuesday's work.